Thank you. All right, so a cargo container has been built using a blueprint. I don't know if you recall, if you go back to scales and scale diagrams, I would definitely use the word diagram, like a blueprint is a diagram, right? With a scale of 1 to 15, no units, that's actually perfect. So I can immediately just take that and turn that into a scale factor, just like that, okay? Perfect scenario, very little work needed to be done, right? If the capacity of the blueprint, right, has this many cubic centimeters, so even if you don't know what capacity at the moment refers to, just look at that cubic centimeters, right? So we're talking volume. Determine the capacity of the actual container. So I'm going to use, because of that, I'm going to use this formula, K cubed, right, is volume of diagram over volume of actual. Does that make sense that I use that? Okay, so now I'm going to plug in what I know. I know my scale factor. I don't need to find it. Okay, just make sure you cube it. And I'm given the volume of the blueprint, which is the diagram, right? Again, diagram. So I just plug that in, 588.25 cubic centimeters. And this is just going to be my unknown, which is going to be in cubic centimeters as well, because those are the only units that are there. So let's go ahead and do that. I tend to cube each number separately, right? So 3 cubed, sorry, not 3, 15 cubed is 3,375. Thank you. So 15, right, to the power of 3, there it is. I like to keep it like that if at all possible. And then we have 588.25 cubic centimeters over x cubic centimeters. And at this point, you just cross multiply and divide, right? So x is equal to 588.25 times 3,375 divided by 1, which is irrelevant. But there you have it. This would be 198.43.75 cubic centimeters. Could it be that I asked you to convert this into cubic meters? You should be able to do that, right? If I asked you to do so, but it doesn't, so we're just going to go with that. Okay. And it makes sense because the actual container should be much, right? Should have a much larger capacity than using the diagram or the blueprint measurements. So there you have it. Okay. B, the amount of sheet metal required to build the actual container, right? The actual container would be this many square meters. Determine the amount of sheet metal required to build the container on the blueprint, right? The container on the blueprint is what they want. Okay, so because of the square meters, right, we know that if we're comparing areas or surface areas, we need to use k squared because the surface area are affected by a factor of k squared. So I'm going to go surface area of diagram over surface area of actual. And k hasn't changed. It's still 1 over 15. I'm going to square that. Surface area of diagram is unknown, right? That's what they're asking us for. So what we have is this bottom piece, right, which is in square meters. Remember to square this. This could be a number other than 1, right? If it's 1, it's nice and easy. It just stays 1. 15 squared is 225. You can call that x, right, over 139.05 squared meters. And here it is. Our answer is 139.05 times 1 divided by 225. And that is 6180. Sorry, I'm off. 0.618 squared centimeters. Because it's finite, I just use the whole thing. There we go. So just be careful what your starting point is. In this case, it didn't ask us for the scale factor because we already knew it, right? So it ends up being a proportional reasoning type of scenario. All right, I want to do a table with you. So let's go to 41. We're making a bunch of spheres. Okay. When you have a table like this, find your original. I already gave it away because it says right there, original. How do you know though this is the original? Because you have everything filled in. You know the radius, you know the area, the volume. So this I'm going to highlight as our original. So that's the first thing you need to identify. And now we're going to make various copies of that original. We're going to make some that are smaller, right, perhaps, and some that are larger than it. Okay. The next, I would say the next thing you need to focus on is the scale factor. So once you have the scale factor, you're good to go. You can just go to town and fill in the rest. Okay. So here we go. Obviously, it has a scale factor of 1 because it's just itself, right? So let's go to the very first copy we're making. So this is new number 1. We don't have the scale factor. So you're going to compare corresponding measurements. And you notice that the only two that you know would be the radius. You see that? So you need to use radius. Radius is one-dimensional, okay? So we know that K is going to be radius of new over radius of original. That's how we're going to find our scale factor. And so all you do here is the new one is 1.35 inches and the original is 7.5 inches. Cancel that out. We can just divide and just get a decimal, that's fine. So use your calculator. Right, 1.35 divided by 7.5, and that's 0.18. If it continues, use 4 decimals, okay, guys? So that it's more accurate. There we go. That's K. Now that we have the scale factor, we can fill in the rest. Okay, guys, this was the key. Step number 1 is try to find a scale factor. In this case, all we had was we had the radii, right? Both of them. So to get the area, I'm going to use the shortcut K squared times area of the original. Right? And to get the volume, you go K cubed times volume of the original. Because to get this new one, you just apply the scale factor, right? So here, to fill in this chunk, we go 0.18 squared times 70686, and that's going to be our answer. 0.18 squared, just make sure you square it. I kind of just tend to figure out what that is first, and then I go times 706.86. And this is 2290. And we are in, go back to where you started, squared inches. Inches squared, right? Next, to fill in the volume, we go K cubed times the volume of the original, which is 1767.15. Grab my calculator. To the power of 3. Multiply that by 1767.15. And there you have it, 10.31 cubic inches. Yikes, breaking everything. Cubic inches. And there you have the full shape filled in. Okay. But there are variations of this. You will see. Let's do the second one. Forget about the first one now. You're done. Okay, let's go back to the original, and we're making copy number 2. This is our new shape here. You want your scale factor because you don't have it. Which 2 measurements do you have? You have both areas, correct? So watch this carefully. You have to make sure you go k squared is equal to area of new divided by area of original. You have to use k squared, not just k. K, I'm just trying something here. So new 254.47, and they're going to cancel out, so I'm not going to show that. 706.86. Okay, so watch what I'm going to do here. I'm going to show you k is the root of that, of this, because I'm taking the root of both sides. It's a little tight, I know. On a test, I will give you, I will give you some space underneath a table like this to do your work down there if you'd like, and then come back and just fill in this table. So watch carefully how you type this in, right? You divide, right? And then I go square root, which is second x2. I go copy that, paste it in, and you get 0.6. Now that you have your scale factor, you're good to go. This is very important. You're going to go k times 7.5 to get this. K times radius of the original. So 0.6 times 7.5. And that is 4.5 inches. Don't square, don't cube, because it's one dimensional for this one here. Right? Oops. Before you go, just look at Google Classroom. I'll post the questions that I would like you to try, okay? Because it's basically prep for the test. Okay, so just look online. I will post it.